find f prime of x. F of x equals 4x cubed minus 3x cotangent x. Okay, number two things. If you don't know the derivative of cotangent, you're out of luck, so hopefully you've memorized that. And then the second thing I noticed is that this second part of the problem is a product, so we are going to have to use the product rule. Okay, so we can go ahead and take the derivative of the first part just like normal. So the derivative of 4x cubed is 12x squared. All right, to take the derivative of the second one, I'm just going to bring that minus down, and now I'm going to be applying the product rule. So f is equal to 3x, and g is equal to cotangent x. So f prime, the derivative of 3x is 3, and then g prime, the derivative of cotangent is negative cosecant squared x. And now we're ready to apply the product rule. So f prime times g, so it's going to be 3 cotangent x plus f times g prime, so 3x times negative cosecant squared x. And then from here, I'm just going to clean things up. I'm going to distribute that negative inside. So I'm going to have f prime of x is equal to 12x squared. This will be minus 3 cotangent x. And then this negative times this negative will turn into a positive, so it will be plus 3x cosecant squared x. And of course, we can't combine this x and this cosecant squared x, those x's, because this x is involved with the cosecant right now. Okay, and we could go one step farther if you wanted to. I wouldn't count you off if you did or didn't, but I do notice that we could factor a 3 out, so if you would like to do that, we get 4x squared minus cotangent x plus x cosecant squared x, but that is totally up to you if you do that or not. Okay, number 12, find the x value of any horizontal tangents of the curve y equals x cubed minus 7 halves x squared minus 10x plus 4. Okay, horizontal tangents would be where the derivative is equal to 0, because we would have horizontal tangent lines going on. So the first thing we want to do is find the derivative. So the derivative of x cubed is 3x squared minus the derivative of 7 halves x squared will just be 7x, and then minus the derivative of 10x is 10, and then the derivative of 4 is 0. So that's my derivative. Now we would like to figure out where does that derivative equal 0. And I notice since this is a quadratic trinomial, I'm going to be using the magic number trick. And then I'm going to take the 3 times negative 10, which would give me negative 30. What times what would give me negative 30, but add to give me negative 7? That would be minus 10 and plus 3. And I'm going to reduce that part of the problem down. So I'll have 3x minus 10, and then x plus 1. And again, we're still equal 0. So if you have something like this, you can now use the 0 product property, which means to set each part equal to 0. Okay, so in this one, if we add 10 to both sides, we'll get 3x equals 10, and then divide both sides by 3, we'll get x equals 10 thirds. And then on this side, if we just subtract 1, we'll get x equals negative 1. So that would be the x values where there would be horizontal tangents. Okay, 13, find the derivative of 5x to the negative 3 times the quantity 2x to the 5th plus 3x squared. We could bring this 5x to the negative third down to the bottom and use a quotient rule, but it will probably be easiest to distribute first. We can't just take the derivative of each part, so we'd have to use the product rule or distribute first, which I think is easiest. Okay, so when we distribute, 5 times 2 is 10, and then x, if we add our exponents, negative 3 plus 5 is going to be x to the second, and then plus 5 times 3 is 15, and again, if we add our exponents, negative 3 plus 2 is negative 1. So that's the function that we're going to be taking the derivative of. And then if we take the derivative, bump my 2 out front, I'm going to get 20x, and then plus negative 15x to the negative 2, because remember, we're subtracting 1. And now I'm just going to clean it up so there are no negative exponents. So we'll get 20x minus 15 over x squared. Okay, number 14, find d squared y over dx squared. Remember, this means to find the second derivative. Okay, and again, hopefully you know the derivative of cosecant x, otherwise we're going to be in a little bit of trouble here. Okay, when we're taking the derivative of 5 cosecant x will be negative 5 cosecant x cotangent x, and then plus 2. All right, now from here, if we want to take that second derivative, I do notice that we now have a product. This would be my f, and this would be my g. So in order to take the derivative, I am going to need to use the quotient rule, the product rule. F prime, the derivative of negative 5 cosecant x will be positive 5 cosecant x cotangent x, and then g prime will equal the derivative of cotangent x is negative cosecant squared x. All right, so now I'm ready to take my second derivative, and I'm going to come down here so I have a little bit more room. Okay, so we have f prime times g, so we'll have 5 cosecant x cotangent x times cotangent x plus f times g prime, negative 5 cosecant x times negative cosecant squared x, and then plus the derivative of 2, which would just be 0, so we don't even need that. Okay, let's clean up here. So I'm going to have 5 cosecant x, cotangent times cotangent will be cotangent squared x. Notice where we put the squared, we don't put it with the x, we put it right in the middle. And then a negative times a negative would give me a positive. I'll have 5, I now have 3 cosecants, so cosecant cubed x. And then we can go one step farther than from here because they both have a 5 and they both have a cosecant x. So if I factor that out, my second derivative will equal 5 cosecant x and then 5 cotangent squared x plus 5, oh, no 5 anymore, sorry. And then cosecant squared x. And then that would be my answer. Okay, number 15, find y6 if y equals negative 4 cosine x. This means to take the 6th derivative, not the 6th power. So we just are going to keep going back and forth. No product rule necessary because there's no x in front of the cosine x. So the first derivative, keeping in mind that the derivative of cosine x is negative sine x. This will be positive 4 sine x. And then the second derivative, the derivative of sine is cosine, so it'll be 4 cosine x. And then the third derivative, the derivative of cosine is negative sine, so it'll be negative 4 sine x. And then the fourth derivative, the derivative of sine is cosine, so we'll get negative 4 cosine x. And then the fifth derivative, the derivative of cosine is negative sine, so it will turn back into a positive 4 sine x. And then the sixth derivative, the derivative of sine x is cosine x, so we'll get 4 cosine x. And then that should do it for that one.